Thanks. Room is filling up. Nice. So welcome everybody to today's talk about POM-less Tycho builds. My name is Sievers, and I'm working for SAP, and I'm a co-lead of the Taiko project at Eclipse, together with Igor Fedorenko. Very short overview what we're going to talk about next 35 minutes. I'm going to give some background and introduction of why we actually came here to try to get rid of pom.xml, and then I'm going to have a short demo, and hopefully we'll have some time in the end for discussion and question and answers. So this seems to be about getting rid of pom.xml. So why do we have pom.xml, something like POM in the first place? So just to recap, Taiko is a Maven plugin, and Maven has a project object model which is really fundamental to anything that you can do in Maven. So the POM defines really the fundamental metadata for any artifact that you want to build with Maven. So any jar, for example, you want to build with Maven and you want to publish with Maven, it needs to have a POM. And there are some bare minimum required metadata that goes along with this POM, such as the so-called GAV coordinates. So there's a group ID, an artifact ID, and a version for each Maven artifact which exists in the world, and this is used to uniquely identify it. Then there's also things like a packaging type. So like, is it a jar or a var or any other type of artifact? And the POM is also used to configure your build or your plugins that hook into the build lifecycle. And the XML representation is basically the entry point for the build, and it's what drives the build more or less. So for POM first, or for, let's say, classical Maven builds, the POM also defines, for example, the dependencies that an artifact has. So in a nutshell, the POM is the artifact metadata master for Maven, right? Now you know that there's also, since Taiko is trying to provide a way for Maven to build artifacts in a manifest first approach, there's also another approach, which is what PDE more or less defined. And this is actually in contrast to what we just talked about. So in this case, you have the OSGi manifest as the fundamental metadata for any OSGi artifact. So there are things in there like bundle symbolic name and bundle version. And so this pretty much sounds similar to what we just discussed. And also the dependencies are declared in there, so you have require bundle or import package. So for PDE, it's the OSGi manifest that is the artifact metadata master. And so you see that there's some kind of conflict here when we try to marry these both approaches and have a build that is run using Maven. So what Taiko is essentially doing is trying to bridge this gap, all right? So it bridges the gap between the POM first, I call it POM first as opposed to manifest first, classical Maven world, and the manifest first Eclipse OSGi world. And there's a statement on the Taiko homepage, I think that's from the original, I think it's from Jason Van Zyl, who originally contributed the project to Eclipse, saying that one of the important design goals in Taiko was to make sure that there's no duplication in metadata between POM and OSGi. Now, you can, if you try to bridge these two approaches, you can come up with mappings. So there's one fairly straightforward mapping that Taiko is using to try and come up and find equivalents on both sides. So on the OSGi side, you have a bundle symbolic name for each bundle, and we map that to the artifact ID because it's pretty much equivalent. Same goes for the bundle version. We map that to the artifact, the POM version. In terms of features, if it's not bundles but a feature which you build, there's also a very straightforward approach. Each feature has an ID, and this is mapped to the artifact ID of the Maven artifact. Each feature also has a version, and that's mapped to the version of the artifact. So that's straightforward. There's just one special case here, which is worth mentioning, and that is for the auto-incremented development version. So if you know PDE, there's a magic suffix that is being used during build for versions that says .qualifier, and this is typically replaced with a timestamp, so that each build will give you a new and incremented version. And it turns out that Maven, independently of that, has a very similar concept, which is called snapshots, and there you have a suffix -snapshot, which is also replaced by a timestamp. So,
I have a question to that.
Yeah.
Could I also use in my manifest snapshot, and would that also work with Taiko?
No, so these concepts are actually, these concepts have come up independently of each other. So Maven has existed for a long time, and PDE has existed for a long time before someone started to bring them both together. So qualifier is strictly PDE world, and -snapshot is strictly Maven world. And
PDE to snapshot, would it work with Taiko?
so you could start and try introducing a new magic suffix, but since it's already there and it's just a matter of mapping them, we didn't. We just try to, try to bring these things together. And since the concepts are really similar on both sides, we just map them onto each other. But what I just told you is basically, okay, we have double maintenance here, right? So we need to make sure that these mappings are respected. And the problem is that the manifest as well as the pom.xml are both source level artifacts, things that you edit. And when you change one, you need to keep the other in sync. So this is the problem, right? So double maintenance is what we used to have up to recently, and of course that's not nice. And there's a long-standing bug that was just resolved now about this. And so you could say, why not simply, if there are such simple mappings, why not simply derive the POM from the existing OSGi metadata? And up to recently, you could think about that, but there were several things that would make this not very practical. One is that Maven used to strictly require the XML as a serialization format for the POM, right? So it would hardcode more or less that if you want to start a build, there has to be a POM.xml in the file system, otherwise it won't start anything. The next thing is you could think about generating the POM.xml, but that would mean before each build you would have to have a generation step, next step, people would forget it. You would have to read a README like, how do I build? Oh, I need to generate first. And then once you're done, you would leave garbage because the POM.xml is not something you want to keep, so that wasn't really practical neither. And then some time ago, Maven 3.3 came up with a new so-called core extension mechanism, which is really helpful in this regard. So Maven always used to be extensible on a very low level in the sense that there's a libext folder somewhere in the Maven installation home, and you can put jars in there, and they are in the lowest level of the class loader hierarchy. They are available and you can start exchanging things there. But this was also not what you really wanted, because you want someone to sync your sources, Maven clean install, and the build just works, right? So what happened in Maven 3.3 is that this mechanism of putting jars into the lowest class loader hierarchy level was actually extended to be declarative. So there was a new descriptor that you can add to any Maven build in your top entry level directory, .mvn extensions XML. And these extensions are not like other build extensions where you would just inside your POM register new plugins which you want to use. This is really low-level extensions. And the important point here is that these are evaluated before even the first POM is passed. So that is the key to being able to break out of the XML serialization. And we just keep the POM, right? There's a memory model for the POM Maven project that is being deserialized from the POM XML. And but in the memory model, there's no, so in the existing code, there's no hint to XML. So what was done simply is to make the serialization pluggable. So XML is the default option, but you can also use other serializations now. And this is what people did. And so some people around Jason Van Zyl started to prototype things and play around with what they called polyglot Maven. So in the sense that Maven can speak other languages, in the sense that other POM formats. And things, this is an example. So there are several proof of concepts there. One of them is, for example, YAML. So if you compare that to the equivalent which you would have in XML, it's quite terse, right? But it's just an example. People have come up with Groovy and Atom and other formats. So when I saw this, I was thinking, okay, maybe we have a chance to do something about our duplication here. So I guess you get the idea. We want to derive the POM from the OSGi metadata, and we already have all these mapping rules. The point is just that up to now, the mapping rules were simply validated, and you would have to make sure yourself that you respect them. So why not take these mapping rules and put them into code, right? So that's what we did. We registered a POM deserialization that simply gets information from an OSGi bundle manifest or from a feature XML, and then uses this information to build up the same memory model we used to have before. So we discussed the mapping rules earlier for the IDs and for the versions, so they are there. In Maven, you need an artifact ID and a version, that's covered. You need a group ID. That's not really straightforward, but we resorted to inherit that from the parent. So that's where, I mean, we have another, maybe we can talk about that later, but you still need some kind of build configuration that's not in the existing OSGi metadata, so you still need a parent POM, all right? That's the thing that remains. And then, of course, the packaging type is simply as per the file that is being detected. So if you have a manifest, it's an Eclipse plugin. If you have a feature XML, it's a feature. And then there's also a special case when you have a manifest, and by convention, we just say, okay, bundles that have a symbolic name ending with .tests, as is the normal convention in the Eclipse space. We use Eclipse test plugin as a packaging type, which will make Taiko automatically execute any JUnit tests that are found inside this bundle. All of this being said, so this is the default metadata. Now, of course, you can configure much more in the POM, and sometimes you need to do that. And so the point is, we still leave the option in to configure stuff. So sometimes your tests need a special setup or something like this. And you wouldn't be able to put this setup in the manifest, right? This is simply a runtime artifact. So when you keep the pom.xml, it's still respected and it has higher priority. So let's do a demo. Okay, may have to zoom in a little bit here. So I'm using, is this legible? Yeah. So I'm using the Taiko has a demo project that simply is a very simple RCP app. And I cloned this as is, and now I have some, sorry, I need to zoom out. I'm running the Maven build. And this is a very, very simple RCP, bare bones, just for demo purposes. So we can build this, just to show you it works. So this is unchanged. And if I would open the thing that I just built, you can see here, okay, it's a small, there's nothing much in there apart from some hello world message, right? Okay, so that's the starting point. Now let's do the case that actually started us. So we have this double maintenance. There's a manifest here in a bundle, and it has a version 0100 qualifier. We also have a POM that goes alongside. And it has the matching version 010 snapshot, okay?
Unreadable.
So I have a manifest with this version and the POM that goes with it with the matching version which we just talked about. So let's say I'm a developer, I'm just concentrating on getting my stuff done, and build is not my main concern. I changed my version because I did some changes here, and I would run the build again, and sorry about that. And I would get an exception saying, look here, your version can't be validated because you have 020 qualifier and 010 snapshot that doesn't match, right? So that's not nice. And I would have had to really change this version here and then start the build again, and then it would be fine. But if you imagine someone forgot about it and the nightly build failed, maybe that's not so nice. So now let's try to get rid of this duplication. Let's just finish this build. I'm going to go ahead and take this build and just simply delete the pom.xml of the bundle, right? And once I build it once more, of course I get a failure, and it complains that this example bundle pom.xml can't be found, right? It has no, there's a bundle being referenced in the parent, and so we have the module list here, right? You have the example bundle, it's referenced here, and it can't find it because I just deleted the POM. But now I'm just going to add this new build extension to show you how that works. So I have a extensions XML here, and I put that into the root of my build. And in here, I just say, okay, I have an extension. So this is part of the latest Taiko release, just just released a week ago. Right, so we just specify the coordinates of the Taiko POM-less build extension here. That's all we do, and we start the build again. And see how that goes. And we have a working build again. I can even go ahead and, as I told you, we do the same thing for features. We have 2 features here. I'm just gonna, okay, build, sorry. That's too big. I'm going to take the features and also delete the feature POMs. There are 2 features here. Delete. Okay. Run the build once more. And we still get the same result. There's one small hint here that probably nobody saw. But in the start of the build, you have these spurious debug messages. They shouldn't be there. They are gone in a newer version. But this is just a hint to tell you, okay, this new build extension actually got invoked and created a POM on the fly. So I'm just starting the stuff again, which we just rebuilt, just to see it still works. And it's the same thing. So we have this hello world example again. And I think this was about it, which I wanted to show. Let me. Maybe one more thing. I told you that the manifest and the feature is being used to build up this in-memory model of the POM. So the POM is unchanged. Everything is unchanged for Maven or even for Taiko. Taiko doesn't know that the POM model actually didn't come from XML. It came from somewhere else. But there's one point which I may be able to show you, that there's still a POM, although we have no POM here anymore, right? We have deleted all the POMs for the bundles and the features. But when you install your artifacts into your local Maven repo, and I'm just looking at the bundle here. Is that, yeah, legible? So you see that, okay, 11, that was just done, right? More or less. We have this. No, it wasn't done now. Oh, I changed the version number. Thanks. Yeah. So, yeah, that makes more sense. We still have a POM here, so that's the serialized version of what we just passed, starting from a manifest. And this thing looks all the same as it was before. It was just generated starting from, not from pom.xml, but from the manifest. Okay, this is it for the demo, I think. Right, so we saw that we can actually remove the pom.xml for any bundle or any feature that doesn't have specific configuration apart from the standard, like the GIV coordinates and the packaging type, which is normally the case for 90% of the builds I know. But there are still some things to consider here. So why did this actually work? I also talked about the group ID. So the group ID is inherited from the parent POM, and we need to make some assumptions about where do we get the parent POM from. And the simple assumption is that it's in the parent directory, which is also the default for Maven. If you don't put your parent POM into the parent directory, right now this is not going to work. But there are ways to refactor your existing build to comply to this convention. And with POM-less, I didn't want to say that there's such a thing as a completely POM-less build. I mean, there needs to be some kind of build level information, like which are the P2 repositories you're building against, and even more. And typically that goes into the parent POM. So you will still have at least one POM XML in your build. But for the bulk of your bundles and features, the POM XMLs are no longer needed, and you don't need the double maintenance. I think I would consider Taiko POM-less the most useful for those projects that do manual versioning. Like you do semantical versioning and you change your version numbers according to your API changes. And that's where you're most prone to, let's say, changing the version in one place and forgetting about the other place. And so it's not like we didn't survive up to here. And there were tools, even though there was this duplication of versions. So Taiko versions plugin, maybe some of you are using it, was another workaround for this double maintenance problems, where you could actually consistently change POM and manifest and feature versions for a whole bunch of bundles or features. The point about Taiko versions plugin is simply that this doesn't go together with semantic versioning, because what you would do with the Taiko versions plugin is make a bulk change for all the bundles and all the features, and you would probably version them together. So that's another way of versioning, and which also works, but it's not semantical versioning. Another thing maybe to consider is that when you change for POM-less, that means you also no longer use the Maven Eclipse tooling to manage your IDE project, right? But I guess that's a given, because most people would use PDE projects anyway, and Maven was kind of a add-on there, and you remove that back when you don't have a POM XML anymore. So that's it, and I would like to open for questions.
Is there a possibility to have the automatically generated project object model merged with some additions that I have done to download, for instance, additional dependencies and copy them to feature root files?
So the question was if there's some kind of hybrid way to get the version and artifact metadata from the manifest, but still be able to get other things I would want in my POM XML and merge it. Not as of now, and I think we had this question, I think, on the mailing list or in Bugzilla. I would think it's the point about this thing was to simplify things, and if you would start pulling information from 3 different places and merging them up, I think it would really complicate stuff and get. I'm a bit opposed to that as of now, because also, let's say the Maven Eclipse tooling, it assumes if there's a POM XML, it's a POM XML. I mean, a full POM XML. You can't just leave out the GAV information, and so that's why I think either you get rid of the POM, or if you need it, you still have it, and you have a full one then, and that's the compromise. I think you can, in most cases, you can try to pull up most of the stuff that you need to configure into a parent, so you don't mix that up with the actual bundle and feature POMs.
Can I leave out the POM for some of my bundles, and for instance in the feature I specify a POM and have a hybrid approach on the bundle versus feature level?
So question was whether you can leave out the POMs only for some of your models and for the others you leave them in. And I think I mentioned this earlier. Yes, you can. So if you still have a POM.xml, it takes precedence. Because there are these cases I know about where you actually need to configure something in the POM and there's no other place to do it. So that's the reasoning behind it. Yes?
But you said if you have additional build jobs, for example, configured in your POM and you need one in the test plugin, for example, then you would have to again introduce the double maintenance for the versions because you will have the dev again.
Yeah, so as long as you don't have a common parent POM where you configure these kind of things, if you need very specific settings for a very specific test plugin, then I think there's no way around having a POM.xml because you simply, that's still how Maven works. I mean, there's a Surefire plugin in Maven and it expects to be configured in a POM.xml. And yeah, what we have as metadata is the manifest, and that's simply limited to what is available in the OSGi runtime. So there's a difference between stuff that's relevant at OSGi runtime and stuff that's relevant at build or test time. And there's simply no place to put it other than the POM.xml for the build-specific stuff.
But wouldn't it be a solution to still derive the parameters from the manifest that are there and add the build steps additionally?
Yeah, that's what, I mean, that was the first question was about that. Yeah. And my point was, you can't have half of a POM.xml. Because M2E will be completely confused. And I think it's going to add a whole slew of problems, which I don't think is worth it. Yes?
You've shown how to build snapshots, and you said that the qualifier is mapped to the snapshot keyword.
Right.
Does that mean for building a release, you would have to remove the qualifier?
Yeah, so building a release, yeah, for release, I didn't talk about that today. Maybe that's the topic of yet another full talk, because releasing in Maven also has a certain, let's say, Maven has a certain idea of what it means to release, right? And that's something you also need to map to what do you do when you release a bunch of bundles. So when you release, I think the Eclipse platform build, for example, they never really formally release in a Maven sense. They have a qualifier, they keep the qualifier, and the qualifier is based on actually latest Git commit, so that means the qualifier will stay stable if you check out the same commit. I have something in the works, there's a bug for it, about freezing the qualifier. So I did a POC, and I may find some time to work on that, where there's a small tool that can be used to freeze the qualifier more or less. Like you have in normal development mode, you have a qualifier, it's always incremented, or it's based on the Git commit. And I did a small tool that it's not in the master branch yet, where you can say freeze qualifier. It'll take the build, compute the qualifier, and put it into the manifest. Instead of little world qualifier, it'll put the computed qualifier in there. And it'll do the same thing in the POM, if there is one. If you don't have one, then it doesn't matter, as we saw today. And that's the way I see you could actually do real Maven releases, because a Maven release means no snapshots anymore. Yeah.
The detection of test plugins somehow configurable?
Not right now. So right now I more or less hard-coded ends with .tests. The problem with making it configurable is that these Maven core extensions are so low level that I mean, you can't configure them in the POM because they are loaded before the POM, right? So you have a chicken egg problem there. I would have a hard time. Maybe there's a way to configure them. I didn't look into the details yet, but it's not the straightforward way you would do with other Maven plugins. But yeah, maybe that's a future enhancement.
Would it be possible to add a custom field to the manifest MF file, for example, for the tests? So if you put it in tests, then it's considered to be a test plugin?
Yeah, you could think about that maybe, yeah. But there are all kinds of ways. Yeah, I mean the manifest.
Yeah, that's possible, but
yeah, it's many of these things are about conventions, right? So stick to the convention, and you have less code to write, or you don't stick to the convention, and then you have more stuff to configure.
But you can also, I think you wrote this a while ago, you can use a SAML approach, huh? So you can combine this. I think you can use POM-less approaches and then write something else, like a SAML to do something else, huh? Your own extension.
Yeah, you can. I played around actually combining several of these polyglot dialects. Is that what you're referring to? So Taiko POM-less is you can interpret it as a Maven polyglot dialect, and this YAML thing is another dialect. And at one point I had them running even in a combined way. Today I didn't get it to work, so I didn't show that. So yeah, but that would be to explore. I think it should work even to combine different flavors there. But there's also, I mean, there's some value in a pom.xml if you want everybody to be able to understand or be able to read your build at a glance. If you start using stuff nobody else uses, maybe there's a legibility problem then. But that's true anyway for these build extensions. So there's a trade-off there.
So when you have the mapping of the artifact that you from feature and bundle, it may be that you get conflicts because the bundle and feature have the same ID.
Yes.
So what's the fastest way to group up features together?
Yes.
How could you do that with the POM-less approach?
So the question was, what about bundles and features that have the same IDs? Don't you get a name clash there? And the workaround was to use a different group ID, and you can still do that because the group ID in this approach is configured in the parent POM. So you can have a feature parent and a bundle parent. They have different group IDs, and you have the same thing as before. Okay.
So I'm not quite sure if I understand it correct, but if I want to start with this, do I have just to put the extension XML in the root of my project and remove the POM XML? So
right. So all you need to do to try this out is, as I showed, you need to put this extension XML in the root of your build. You remove. Let's start with one bundle to see if it works. You remove the POM XML, and there's one caveat, and that is your parent POM needs to be in a parent directory. And you need to use Maven 3.3 or later, because these build extensions were only introduced with Maven 3.3, but that's it.
Can you just show the extension XML? You showed it, but it wasn't good to see.
Okay, the extension XML is pretty simple. It's basically just referring so it's a very simple descriptor. I don't think there's much more to it. You can register an extension here, and that's a Maven artifact, GAV, and that means it's being downloaded and added to the class, to the Maven class path. That's all you need. All right, are we done with time? Or okay. Thank you very